So first of all, thank you for being here for the July Sustainability Series. We're really excited today to welcome EggGeo and members of the EggGeo team to provide this presentation. As I mentioned, we're kind of sharing one computer and trying to figure out how to do this on a bigger screen. So we're going to be all in the same room, all talking at different parts of the presentation. And appreciate your patience with us, and hopefully you don't get too dizzy as we're doing that. As usual, if you have questions, please feel free to type them in the chat. The presentation today will be around 40 to 45 minutes is kind of what we're shooting to leave plenty of time for questions. And with that, I am going to get out of the way and introduce Jay Egg from EggGeo to give a presentation today about thermal energy networks. And welcome, Jay.
Thank you. Thank you so much, Kevin. We're going to switch seats. What I'm going to do for the listening audience is just put the computer this way. And if you can see in the gallery view, you can see we have Greg Cunniff, our professional engineer that is our hydronics expert. We have Carter, who is our geothermal scientist, and we have Christy back here who will be speaking in a little bit. And we're just going to go through some of the things that are going on in Rochester with thermal energy networks and how they're using thermal energy networks to be able to reduce combustion and electrify buildings. Do you have access to be able to let people in already?
I am working on it.
Good. I will continue. Every once in a while I'll pause, and I'm going to continue to let people in until till Kevin gets through. So what we have on the front here is an image of a thermal energy network for any town USA. On the front screen, we also have a drill rig that is actually operating, that the city of Rochester has commissioned to do their city hall. Let's see if I can figure out how to get these to advance here. The right, it's not about enter. I'll find it here. Admit. I don't see an arrow button. Do you see it, Greg?
You just click on it.
There we have it. So moving ahead, a little bit about EggGeo. We've been in the business for quite a while. We started out as a contracting firm roughly about the time much of the industry was really kicking into business. We had a Central Florida engineering and contracting firm, and we have long worked with national laboratories and other folks to help validate geothermal systems. A little history on my family. My grandfather was in the mechanical business way back in 1948, and so does Springs, Idaho. He's the only plumber in town. So it's something that we have continued the legacy of throughout the years up until the present time. We have a lot of writings and a lot of articles that we do to help educate the industry. A lot of kids, that's right. We do have a lot of kids. And you can see here some of our educational efforts has really begun to focus in the last 10 years on the rising generation and kids. So you can see the reading, we've become ambassadors for this new children's book that was released worldwide. And Christy will talk about that a little bit later. But what we're going to do right now is talk about the basics of heat pumps and geothermal systems. A geothermal system, or any heat pump, like you see on the right side here, operates exactly like a refrigerator. A refrigerator uses a compressor and other refrigeration components to ensure or to enable it to remove heat from the box. And that's how the box gets down to 40 degrees while it's still 72 degrees in the kitchen, and the freezer gets down to 5 degrees. That's the same reason why when it's 100 degrees outside, you can use an air conditioner and pump heat out of a building to the outside and take a 100-degree outside day and turn it into a 72-degree comfortable temperature. We do that and we measure that using something called coefficient of performance. And without getting too deep into it, because I want to keep this moving, let me just tell you that coefficient of performance for a heat pump simply means that for every kilowatt of energy we give a heat pump, it can move 3 or more kilowatts of energy either into a building or out of a building. So there are some other slides here. What anybody wants a copy of this slide presentation afterward, please type your email into the chat and Kevin will make sure you get a copy because I'm going to forward this to Kevin when we're done. Here's another example of just how efficient. As we decarbonize and electrify buildings in the built environment, we know that when we decarbonize a building, that means we have to eliminate the burning or combusting of natural gas or propane to create heat. So that leaves electricity from which we can get this cooling and heating capacity. 1 kilowatt of electricity into a space heater will deliver 3,412 BTUs per hour of heat. This is why geothermal heat pumps are so important. That same kilowatt of electricity coming into a geothermal heat pump will allow that heat pump to pump 4 units of energy out of the ground, and mixed with the 1 unit of energy from the electrical grid will deliver 5 units of energy, or in this case, 17,060 BTUs per hour of heat. You can't even compare the difference between these two. And this is the very reason why geothermal systems will allow us to electrify our buildings without crashing the electric grid. This is a couple of, yes?
You might just want to turn a little closer to you. I think people are mostly seeing you.
Oh, got it. Hello, everybody. Thank you. This is a picture, and I'm just using Carrier because everybody knows Carrier, Train, or the bottom line is every major manufacturer has a line of geothermal heat pumps. And in this case, you're looking at a Carrier split system here, which has an outside condenser. That's a standard air source heat pump. Here you're looking at a Carrier geothermal heat pump. The difference is obvious. One has a loop that goes underground, either to a borehole or to some type of infrastructure. And with a split air source heat pump, you have an outside condenser. Now, the outside condenser is supposed to be able to extract heat from the cold outdoor air in the wintertime. And that's all fine and dandy until it gets down below 20, 10, 0 degrees. What do you think happens with the heat pump when it's trying to extract heat out of colder temperatures? It uses more energy. It uses so much more energy as it gets colder that it very quickly approaches not 3 or 4 or 5 COP. It rather goes backwards down to 1 COP, meaning for 1 kilowatt of electricity, you're only getting the 1 kilowatt of heat. And we're trying to avoid that because with a heat pump, even on the coldest day of winter, and we'll just talk about Minnesota here, it's going to be 56 degrees down here when it's -10 outside. And the beautiful thing about that is when it's summertime, it's going to be, when it's 95 degrees outside, it's still 56 degrees inside. I mean, down in the ground. I said inside, I meant in the ground. And that's a much better heat sink to dump the heat from the house. So as we consider these thermal energy networks, a lot of the intangibles are listed here. No more outdoor equipment to replace, more hurricane and storm resistant, greater longevity because the equipment, as you can kind of see in these little houses, is all inside. There's nothing outside, no combustion boilers, cooling towers, or furnaces, which enables or facilitates decarbonization. We have noticeably superior comfort in both heating and cooling modes. The equipment costs essentially the same price as its air source counterparts, and the geothermal wells and piping that you see here are permanent infrastructure. What do I mean by permanent? 30, 40, 50, 60 years. Some people claim well over a century is how long high-density polyethylene will last in the ground. And this is not just something new. We've been doing this for well over 50 years. And you can see examples of city centers putting in thermal energy networks here, of big urban cities. You can see an example of a tap off of a thermal energy network for a 300-ton building here, kind of like what you're looking at here. A lot of different elements and opportunities for thermal exchange are shown here. Let's just move on though. We're going to talk just barely about wastewater energy transfer. Wastewater energy transfer, which is depicted here, is a technology that is non-invasive, meaning you can extract waste heat from the shower water, the washing machine water, and so forth, going down the drain and put it back into your building and provide domestic hot water energy, heating energy, all sorts of things. So geothermal, and I would invite anybody who has some time afterwards and asks for a copy of this PowerPoint to take a look at this YouTube video, because the North American Pipefitter trade unions and basically everybody having to do with trade networks is behind the effort to do geothermal energy networks nationwide. And when I say that, you think about the natural gas revolution in the 50s and 60s. During the 50s and 60s, we did essentially the same thing, except we were piping natural gas into our cities, and we ran 2.5 million miles of natural gas pipelines in our cities. That is the same type of revolution we're looking at now. We are getting ready in city centers like Rochester, Minnesota here, we're getting ready to do thermal energy networks throughout the United States. The good news is each one of these is local to the city in certain networks. Here's an example, and this is the main reason why geothermal heat pumps are the answer and why the federal government, state governments, and city governments are investing in it. This is Greg could speak about this a lot better than I because he authored this, but he's going to have some chance to speak to you in a moment. This just shows the ASHRAE building in Atlanta, Georgia in 2010 decided to put air source heat pumps on the first floor and geothermal heat pumps on the second floor. What you see here is what Texas experienced a couple of winters ago. This energy demand for the air source heat pumps is a direct reflection of the fact that it's harder to extract heat when it's cold outside as compared to extracting the warmer temperatures of the underground, of the earth underground, or of a thermal energy network. And that's just not an isolated case. There are hundreds of such cases. One of them is indicated in this tale of two buildings. In Oklahoma, they built two office buildings side by side, one with air source heat pumps, and you can see the winter peak in February here, and the very same building with geothermal heat pumps ended up having a very low and level energy demand. Another reason we're looking at geothermal heat pumps, I mentioned there's no outside equipment. The wholesale, unchecked installation of air source heat pumps in our built environments results in some very drastic looking installations. Can I just leave it at that and say it's better to do it with a thermal energy network, because not only are these heat pumps going to not function at their optimum efficiency in the dead of winter, but they look terrible and they're hard to work on. As far as this technology goes, thermal energy networks, and you can click on this link on your own time, as stated by Standard & Poor's Market Intelligence in an article that came out last year, are the energy last frontier. 40% of the energy used by the built environment goes for comfort heating, comfort cooling, and domestic hot water. All of this energy can be piped between buildings using thermal energy networks, as you see in the GIF here. This is just, and you can look at it on your own time all you want, in a built environment, anything that is brown is going away because it's no longer necessary. Anything that is, you can see, in this color blue is recover and store, and in this color is reduce and reconfigure. And look at all the things underground we're tapped into. We're tapped into city sewer, we're tapped into subways, we're tapped into building piles. There are energy piles that are structural piles that also transfer heat, and there are about, I would say, 25 different other ways that you can transfer energy. Let's let another person in here. Much like, and so there are so many different ways to do thermal energy networks, and Cornell gives an example here. While Cornell is using deep lake cooling to do non-mechanical refrigeration for their campus, meaning passive cooling, because the lake is 42 degrees year-round, they're in the process of using deep direct use geothermal to power the heating side. On the other side of things, you can go to the Cornell Bloomberg campus in Roosevelt Island, and they are using a loop field. And so they're a standalone building, and they have a central multi-stack heat pump system. What I want you to notice right now is if you go out into the city, especially on a cold winter day, you'll see what looks like vapor rising from buildings. That is heat energy being expelled from buildings that is being wasted. This whole process is saying, let's take that waste energy out of the, and instead of sending it out through the cooling towers, let's put it back down into the ground, into a thermal energy network where apartment buildings and other heat off-takers can use it to reduce their stifling energy bills. And that is the beauty. It's like taking a city and making it whole. You begin to share energy between the buildings and the cities, and that's what we call load diversity. An example of that you can see here in this particular example. There's 5 blocks in this urban setting that have 15 22-story buildings, and these 15 22-story buildings house about 3,000 families. They have a central energy plant that has a 5 megawatt boiler to distribute their heating and domestic hot water energy to those buildings. Once we got into looking at this and seeing how they could be heated, we noticed there was a post office which was rejecting 8 megawatts of heat, even during the middle of the winter, through cooling towers like you see here. We suggested that we could funnel that energy into this central energy plant through heat pumps, and the idea was sound, so they funded the project. This is the same thing that's happening in literally dozens of city centers nationwide and worldwide right now. Geothermal infrastructure belongs to our trades, our union pipe fitters. This is where the gas workers, the boiler maintenance folks, the furnace people, this is where everybody that is currently working with combustibles and natural gas distribution will find very high paying jobs as we move forward. City thermal energy network concepts like you see here tie multiple buildings, communities, and schools together using a multitude of different infrastructure, surface water, geothermal loops, and so forth. The water energy nexus is really what we're talking about, and it has to do with using the movement of water to transfer energy in the form of BTUs. It is one of the most basic and simple uses of water in every form. It has been safely done for generations and has been legislated as a recommended form of heating and cooling transfer. So there are many, and I'm not going to try to explain all of these ways, but there are a lot of different ways to use existing infrastructure as part of a thermal energy network. So this is just to give you a few ideas. The energy, interestingly enough, just as a passing thought, the U.S. Energy Policy Act of 1992 actually suggested that and they made it a law, that houses should use Service water, the water that comes in to provide water for fire mains, for your household uses, should be used as an energy exchange medium for our heat pumps. Interestingly enough, that's where we're coming back to now. As we look at, and I want to turn it over to Greg for just a few minutes to explain these, because he's done a lot of these drawings, how we can use different service sources and sinks for our communities.
Thank you, Jay. What we're showing here is a community thermal energy network. As you can see here, we have pipe that runs around a neighborhood to deliver the BTUs. And then we need a source over here on the left for those BTUs, either to extract from those sources or to reject to those sources. Here we're just showing an example of different kinds of sources. You can have wells, we can have closed loop fields, we can have surface water, and you can also have lakes, rivers, all sorts of sources. That's the interesting thing about using heat pumps, is the heat pumps really don't care what the temperature of these sources are, because the heat pump not only pumps heat, but it can change the temperature. We can increase the temperature of the sources, and we can reject to higher temperature sources. So that's the beauty of the heat pump, in addition to just being able to move BTUs. Here's an example again of the one we showed earlier. One of the interesting things about using the type of technology we're talking about here, this is a single pipe distribution system, not a two pipe. So we just run a loop around your neighborhood, and then you take off from that loop 2 pipes that run into your building and back out. And we either extract heat from that loop or reject heat to the loop. And then you can have loops within loops. We can have an outer ring, which is what we're showing up here. This is an outer ring with the sources. And then we can have inner rings, which are smaller neighborhoods. So we can actually transfer heat from one neighborhood to another neighborhood using this kind of technology, which is different than what you've seen before. One of the other things that we take a look at, because we can now move heat between neighborhoods, and Carter will talk a little bit about this, is being able to move heat from one part of the city to another through these multiple rings. So we can take advantage, like Jay was talking about, in a downtown area, if we have excess of heat because we have cooling dominant kinds of buildings, we can move them into neighborhoods that have residential that are not heating dominant and need the heat at different times during the year. And Jay talked about surface water energy, basically energy that's flowing down that pipe from your city water service. Again, here on the right, we're showing this single pipe loop traveling around the neighborhood, and we can use that surface water to extract heat or reject heat too. One of the other interesting things. Here we're just showing one source and sink to reject heat or get heat from. Realize that at some point we're going to overheat that water, or it's going to drop too low in temperature. So we could have multiple of these sources and sinks scattered around that neighborhood or the city. We don't just have to have one. That's again the beauty of the single pipe technology. It doesn't really care where the sources are plugged into or where you're taking heat off or onto the loop. Again, similar kind of thing here. So with that, I'd like to turn it back to Jay, and then
Actually, Kevin.
back to Kevin, and he's going to talk about what the proposals are in your fine city of Rochester. Kevin.
Sounds good. Thank you. So yeah, we gave this presentation to the DMC board not too long ago, and just wanted to give a little bit overview of kind of the concepts that we're talking about here today and how they're relevant to Rochester. So in 2021, project manager from the city, Scott Ramsey, brought this concept forward. We had initially had some district energy hopes and dreams. State bonding didn't come through, so we kind of had to right size the project based on the budget that was provided to us. With that in mind, you can see the red buildings there at Mayo Civic Center and the library. We're going to incorporate some natural gas boilers. And then also at City Hall, incorporate some geothermal wells that are actually going in and being installed as we speak. So if you're interested in seeing what it looks like, there's a drill rig outside City Hall right now. You can go take a look. The interesting part of this, and something I'll point out, is City Council approved a budget for this project of 15.6 million, and that'll come up later as we kind of move through this synopsis. What this led us to was a considerable amount of gas emissions coming from the Mayo Civic Center, and some electricity emissions as a result of the geothermal wells at City Hall. From there, we kind of embellished on the scope, and what happened over in between 2021 and today was the introduction of the Inflation Reduction Act, or otherwise known as the IRA. As a result of that IRA, which provides federal funding in order to introduce or encourage the adoption of geothermal technology as much as possible, we're able to install 7 geothermal wells, and planning on this, or bring this concept to council on August 7th. This was presented to the DMC board in late June, and install a sewer heat recovery system for the library that's attached to a heat pump. So what this means is all 3 of these buildings, are roughly 750,000 square feet of public space, will be heated and cooled with the geothermal system, and minimize the use of those natural gas boilers as much as possible. As a result, you'll notice the project cost has increased a bit, but the IRA rebate has also increased dramatically as a result of additional wells, sewer heat recovery system, and heat pumps being installed in these facilities. The nice part is the net city cost has dropped. So the City Council approved a budget of 15.6 million. This concept that you're looking in front of you would cost 12.7. So we're saving money by actually doing the right thing, which is very exciting. From an emission standpoint, the results are equally astounding. So in 2025, you'll notice when this system is installed, you'll notice most of the gas emissions go away as a result of minimizing the use of the boiler technology as much as possible in the Civic Center and the library. And in 2030, as a result of RPU's commitment to be 100% renewable, you'll see all the electricity emissions are offset as a result of the electrons coming from renewable sources like solar and wind. So overall, we're seeing a 99% reduction in greenhouse gases as a result of moving towards geothermal. So just quickly looking at the map, you'll see that 99% is spread across these three facilities. Now, something Scott and I have been working on and trying to move forward, and we'll bring a concept forward to City Council soon, is to create a district energy system with this opportunity. So now that we've electrified our city buildings, can we also pass along those same electrification benefits to private development opportunities too? So in the graphic here, you'll see this is the North Civic Center lot. The city selected to move forward with an RFP with Sherman Associates to develop likely some senior housing and affordable housing on that site. You'll see in order to incorporate them into the system, the project cost increases, but also the IRA rebate increases too, because we're incorporating more geothermal wells and heat pumps in order to incorporate and tie the Sherman building into the site. Again,
can I ask you something, Kevin?
Yeah.
So it looks like you have gone to the 3rd generation and you're still below what you were going to do the first time on the first one. That's your point, isn't it?
Yeah.
Because of the IRA and proper management, you are just tripling your influence.
Absolutely.
With the same money.
Yeah. Money goes a lot farther, and the impact of the Inflation Reduction Act is real. So if this is an opportunity, or if you have a project that you've been looking at but couldn't move forward that's geothermal, it's probably time to dust it off and take another look. And then there are some other private development opportunities directly adjacent to the city and private developments we just talked about. The post office being one, the old Post Bulletin site. The city owns this property here that is looking to release an RFP for later this fall, as well as this riverfront area that the city also owns. So what we have is a very proximate, dense area of redevelopment opportunities that could all be tied into the system. You'll notice that the overall cost of this, although the budget goes up, the IRA rebate continues to increase. And with the use of DMC funds to build the piping infrastructure in order to loop these buildings together, now we've created a district energy system. And again, all at a cost less than what City Council has approved for the original concept. So from a greenhouse gas perspective, we're seeing the same savings be spread across all of the buildings that are connected. So in the IRA, or in 2025, the downtown building energy transition, these are the city buildings in that chart that we just looked at. We're adding new private developments, so the electricity emissions are increasing because we're incorporating more buildings that have heat pumps. But again, in 2030, due to Rochester Public Utilities' commitment to be 100% renewable, all of those emissions are going away. So now it was a 750,000 square foot greenhouse gas reduction across that space. We're seeing it spread across a 2 million square foot opportunity. So again, looking at the map, those same greenhouse gas reductions are spread across both public and private facilities, just broadening the environmental impact as well as the opportunity to build the system itself. I bet you're wondering, it sounds great. Capital costs are less, Kevin. We're leveraging the IRA and the greenhouse gas reduction sounds good, but how much does it cost to run this thing? And the encouraging thing is we have the utility cost per square foot here in front of you. So the original plan costs $1.23 per square foot to operate in utility costs. The final kind of at least first stage of build out of the district energy system here is at 98 cents per square foot. So you can see that the heat pump outperformed what we were planning originally from a boiler and small geothermal system at City Hall. When we're able to expand that to multiple facilities, the system becomes more efficient as a result of that, and further savings are realized from a utility cost standpoint. So there's a lot of other benefits from a district energy system. I'm not going to go into all of this, just kind of in the interest of time and make sure we have plenty of time for questions here. But the benefit is this is a highly scalable system. It's highly flexible and provides, and it probably can also help the city accomplish other priorities that it has, like encouraging the development of more affordable housing. Something that we've heard from City Council and our DMC board here locally is to provide more affordable living opportunities. And there's an opportunity to do that when housing is located downtown. The energy costs within that building are as inexpensive as possible, as well as the rents. And really that kind of completes kind of the vision of what I think we've been shared with our boards of creating that affordable living scenario for our community. And the more that we can attach, the more diverse loads, building types to the system, the more efficient and cost effective it will be long-term.
Carter.
With that, I'll hand it over to Carter.
Great, thanks, Kevin. So I'm going to quickly go through sort of an example of what this would look like to install a large district energy system. Jay talked about some of the specific buildings and equipment, and then Greg and Kevin have talked about sort of a general district energy sense, and then I will take a look here at specifically buildings in Rochester and what the process would look like in the coming years. I mean, the first thing that we do is identify sources and sinks, simultaneous demands, things like weather effects in urban areas, and then building on building shading. These are all things that need to be taken into account when determining systems like this.
Oh, letting somebody in. Thank you.
Start counting in. Thanks, Greg. And as you can see here, we've done some preliminary load modeling just to kind of show you what it looks like in these buildings. This is based on just square feet of downtown Rochester. We use a lot of sources for this. Some of it's open source, some of it's building owner cooperation. We look at gas consumption data, geometries, as well as climatic profiles. And this is the preliminary modeling that we've done just to give you sort of an idea with assumed floor-to-floor heights, idealized heating and cooling loads to meet certain room volumes. But once again, this is made better through cooperation with building owners and existing gas utilities. The more information you can get while developing something like this, the better modeling you can do, better sizing for equipment. And this is sort of an idealized district scale output here on the bottom left. And once again, this is generalized. This is just what it may look like. Some of the other interesting sources and sinks around the town, specifically sinks, is the river and then Silver Lake. And I've got to say, looking at this town or looking at the city, there are a variety of really great sources and sinks that can be used to tap into a large district energy system. And I'll go back really quick. We talked about these loops. Generally, we'd start out with sort of a large loop, maybe something that Kevin was talking about down here in really central downtown Rochester. And then you have opportunity to link in other sources and sinks for maybe another commercial loop over here on the left, or smaller residential loops over here on these right, these smaller residential buildings over here. And then from there, I mean, the possibilities are to reach the entire city of Rochester. Another thing to note is that these thermal energy networks grow with the city, like I was talking about. They ensure long-term decarbonization, create a centralized policy action, and they offer individual building solutions to adopters. And so these are some of the graphs we're looking at, some generalized loads, energy savings, and infrastructure onboarding rate. And then this is a slide about sort of complex interactions that happen in a system like this. But Rochester is blessed with a really great network of people who support this project and are really passionate about making it happen. It's been great working with these guys. I think I'll turn it back over to Jay for a minute before we wrap up.
So this is an excellent slide just for people that really want to get their head around this. I have to give Dave Hatherton in Ontario, the founder of Water Furnace, credit for this slide, along with some of his compadres. What he did with this was he proved out we're basically doing what the natural gas companies did in the 50s and 60s. We have a pipe in the ground. The difference is we use something that's roughly the size of a furnace or a boiler to do the same thing plus cooling, which you normally can't get with natural gas. And the source energy is local and renewable, not combustible. With that, I'd like to turn it over to Christy to talk about some of our educational efforts here, Christy.
Hi, I'm Christy Egg. I'm the marketing director for EggGeo. I also have a bachelor's degree in public health, and I'm a registered nurse, so I wear many hats. Well, I wear enough hats. How's that? So basically, I would like to ask you, as the target audience, for those who are interested in sustainability, how would you share the geothermal message? Because we're doing it one way through what I consider to be like a public health. When you're going into a community, you know that you reach those that are low-hanging fruit. By that, I mean the families. If you want to get public health, you don't necessarily go to the dads in the family and say, here's a great public health message, because normally the moms are the ones who do most of the investing in the family's ideals and in their routines. So you go to the moms or the kids. Kids bring home multiple pieces of paper from school. And if you're a mom, you know that. Normally, the ones that are the basic white pieces of paper, what do you do with them? Well, most of the time you don't spend a lot of time reading them, you just trash them. But the colored pieces of paper, you pay attention to. So notice that our geothermal messaging is very colorful. So we're investing in the community. We want to know, how would you share the message? Our idea is coloring books. The book that we're ambassadors for, that's a colorful message, right? We are tying into the idea that it takes everybody working together to invest in the renewables. We know that it's not going to be a light switch. You don't turn off fossil fuels. You don't turn off natural gas. You don't turn off propane, but you do accept the idea that at some point we are going to go from depending on fossil fuels to the electrification of our buildings. Now, Rochester is a really unique place. You are, from your founding moments, at the intersection of tradition and technology. I mean, when Dr. Mayo was out here, Rochester itself was a stopping point between Dubuque and I can't remember the other place, but you're basically, stagecoaches stopped here because you had a great spot. You were near a river and it was a halfway point. My husband's from Barstow, California. If you ever stopped there, it's because you were traveling from either San Diego to Las Vegas or Los Angeles to Las Vegas. That's what Barstow is there for. Nobody wants to live there. Sorry, babe. But it's true. You stop there to get gas and McDonald's, and then you move on. Well, that was pretty much the truth for Rochester. It was named because a guy was from Rochester, New York, and he wanted to pay homage to his place of reckoning. That's why Rochester got its name, right? Well, a year after Mayo gets here, the railroad gets here. Once again, lucky timing, right? But here you are again, have the tradition of the Mayo father and his sons and the incredible globally recognized hospital. But you also have this incredible technology that comes. Well, again, you have geothermal. We have the tradition. Using the heat or using the earth to heat and cool your homes, this is not new technology, okay? But the new technology to put it into a thermal energy network or a district energy network, that is new. It's only new because people are now recognizing it, that it doesn't have to just be a one-off. You can use it in a single pipe or a two pipe technology to go through an entire city. So tradition meets technology, that's Rochester. So how would you share that message? We use the public health dive to get into all communities. Here's a picture of me with my most perfect, most beautiful, don't argue with me, is the most perfect grandchild ever, Darwin, in the right photo. Yes, I'm a nerd. I'm a science nerd. I read my children on the origin of species. I didn't read them the regular fables and fairy tales. And so my daughter named her son Darwin after Charles Darwin. And so that's him holding the blue pen. And yes, he did color all over my copy of the book, Our Hidden Powers. The characters are Wendy, Terry, Sunny, Kai, and Ignis, which is a Swedish word, but he's the main character and he's the power of the earth, heat, the sun, which we in hot rock geothermal dive into. We dig down deep into the earth and use that power, that heat, that steam to turn turbines, but also geothermal is direct use, which is what we use, heating and cooling, HVAC. But the point of the story is that all the renewables have to work together to balance so that we can use renewables to energize the earth without breaking the grid. There's a great PowerPoint slide that Jay showed earlier that had a graphic where the energy peaked out on a green line and then it was relatively flat. Well, sometimes we call that the eagle curve, because you can see that it comes up like an eagle and then the wings come out. That's what we don't want to see happen. That was Texas back in the winter when they crashed the grid. Okay, that won't happen when we electrify if we do it the right way. That's what we're trying to do here in Rochester. So we want to show you that in the winter, in the summer, it doesn't matter. Okay, geothermal is the answer. Geothermal ground source heat pumps. There's a reason that we do this, because we know what we're talking about. All right, diversity of writings. There's a curriculum out there. Jay and Greg wrote a book. Jay wrote a book that the book that they wrote is on controls. It's a upper level, graduate level college textbook. Jay wrote an earlier book that was a more like Geothermal 101. We're ambassadors for the Our Hidden Powers book. We actually have another book coming out soon. When I do the readings, I make little puppets out of the characters. I just color photocopied some of the pages and then cut out little characters, because you have to do that for small kids. They've got to be invested and be part of the story. But you know that if you're a mom or an aunt or a teacher. And then, of course, on our website, we have a geothermal activity book, mazes, circle the word, stuff like that. But these are the things you want to send home or put in your libraries or put in your daycares or just put in your activity bags for kids at Halloween. You want them to become comfortable with the idea and the terminology, the verbiage that has to do with renewables. They have to be part of the equation or it doesn't work. All right. And for me, I want to know, what do you think? This is your city, right? This is what is happening here in your town. How do you bring that home? How do you make this part of your vernacular? Rochester is geothermal, but it has to be something that you're comfortable with. If you only know about wind and solar, then you're missing out on the other half of the story, right? Is it going to be a hybrid system? Sure, solar can be involved, but make it part of the story, make it part of the equation. Because just because you don't see geothermal doesn't mean it's not there. Remember, geothermal works 24/7. If it's cloudy outside, doesn't matter to us. Water's still flowing, your buildings are still warming or cooling. That's the beauty of it. All right, thank you so much for your time. And if you have questions or comments, as long as they're nice, I'm allergic to mean people. Sorry.
I see at least 16 comments up there, Christy and Kevin. Kevin, you want to moderate those?
Sure, happy to. I'll just take down the slide deck so I can see everybody.
You bet.
So here's the whole group here. We had a bunch of questions in here. So Jay, maybe this one's appropriate for you. Is the incoming water coming from groundwater, or in other words, is a geothermal well an open or closed loop?
That is an excellent question. And right here in Rochester, it's so interesting because they've developed a technology where they're using the aquifer, but they're not pulling water from the aquifer. It's called a downhole exchanger, for a whole other training class, but they have a very unique system. So in some places, like in Florida, we use aquifer exchange straight through our systems or through isolating plate exchangers, but here we use downhole exchangers. I hope that answers it. The temperature is whatever the normal aquifer temperature is typically.
Awesome. Thanks, Jay. Can you please discuss any drawbacks and or potential dangers of these thermal energy network systems?
Think about it like this. When natural gas started distributing lines, the 2.5 million lines throughout these cities, I'm sure there was some concern about piping flammable gas into our buildings. Yet they did it, and yet we've survived since the 50s and 60s to 2023 with a natural gas network and with having propane in our houses and so forth. Now, the question might be is, how dangerous do you think it is to bring a water line into your house? What's the worst thing that can happen if a water line leaks? You get a puddle on the floor or you get a ceiling. That is the worst drawback you can possibly experience from tapping into a thermal energy network, is a water leak. And it's a lot better than having a gas leak, I guarantee you.
The next one might draw on your international experience a bit, but being from the UK, it'd be interesting to understand how district heat is viewed currently across the US as an attractive net zero option. How are you attracting local authorities to want to connect?
I think that's a question for you. You're a local authority. How did you get attracted to connect? What brought Rochester here?
Sure. Well, in our case, I think we had a common heating and cooling problem that we needed to solve all at the same time. We had 750,000 square feet of space that was all looking for a way to be heated and cooled. Part of my background is working in higher education institutions, both of which had district energy systems. So as a result of that experience, they weren't geothermal based, but as a result of that experience, understood the value of district heating and district cooling and how those economies of scale can both reduce the cost of the system, but also increase its efficiency. Since then, technology's vastly improved, and having experts like EdGeo continue to install and work on geothermal systems provides additional opportunities for district energy that simply weren't being explored by colleges and universities who largely rely on natural gas or steam-based systems for a long time. So I think the interest is picking up. In our case, it'd be pretty rare for a city to start to build a new district heating or cooling system from an already existing place. So I think from that standpoint, it's a little unique. But really what we're trying to do is just take advantage of the opportunities, and really some could view it as a challenge, right? Where you have 3 buildings that are all losing their heating and cooling solution. But we view it as an opportunity, and are also trying to see how we can leverage that opportunity to help impact other private development here locally.
Would you mention, Kevin, you may not, I didn't hear you mention yet, you had a failure of a steam network, which prompted you guys to go, are we going to fix this or are we going to do something else? Isn't that what really kind of prompted it in a way?
That's exactly right. Yeah, we had these 3 city buildings, the Mayo Civic Center, Library, and City Hall, are all connected to a waste to energy facility steam loop. Unfortunately, that steam line reached the end of its useful life, and to replace it actually costs more than any of the solutions that we showed you earlier, geothermal or not. So it was really kind of that challenge of losing that steam and the heating source for these buildings that led us along this path, and kind of a 6-year project that we're working through as we speak.
Thank you so much, Kevin. And that is what gets a lot of people motivated, and this is that's the perfect time for any city center or state or government to get involved. When you've reached the end of the useful life of a system, it's kind of like what happened in Massachusetts when the gas company said our gas lines are leaking and we need $9 billion to fix them. The local activists and government said maybe we should use the $9 billion to start building a thermal energy network. I see we have another question.
And is there anything done in terms of heating and cooling demand projections to account for changing weather patterns?
ASHRAE would be in charge of that, and they're constantly upgrading and changing. When we do an analysis on a building, it's called a heat gain and loss analysis, and they have, Greg could probably speak to that a little better. How is that exactly done, Greg? How do they account for changing weather patterns? Do they increase the ASHRAE increases the set point for summertime and wintertime according to weather patterns, or how
Well,
is it done in the programs?
If you're designing an HVAC system in a building, right, you size it or you design it for the worst cases, hottest in the summer, coldest in the winter, right? Okay, so there are changing weather patterns throughout the country, and ASHRAE does publish that data, so you can use that data. I'm an old guy and I go back to stuff from 30 and 40 years ago because that weather could go back the other way.
Yeah.
Right?
Yeah.
Whatever it is,
Whatever it is.
whether it's hot or cold. So.
And there's a good contingency in there too, usually with a well-engineered building, right?
Yes and no. You don't want to oversize things too much. We used to use the old IBR ratings, International Boiler, and when you sized a boiler, you added 25% to the capacity. That was just the way you derated things. Well, we don't do that anymore.
Thank you.
we're sizing it to meet the load that you expect.
Fantastic. Thank you, Greg.
I guess the other thing is we haven't necessarily done this here, but one example from Harvard of I think what you're getting at is there are a lot of climatologists that worked at Harvard to predict what would the climate be like in 2050 and 2070. And in our case, we're like, well, what climate, understanding what those temperatures would be in Cambridge, Massachusetts, what climate currently exists in the United States that kind of represents what that climate might be in the future. So for us, we were doing 2 energy models to evaluate our buildings. One that was Cambridge based for the temperatures today that we would expect. And one was actually from Virginia in order to project what our heating and cooling needs might be in the future in order to evaluate what building decisions we might make today in order to account for what might be coming tomorrow. So it's a really good question. We haven't quite got there here with the Rochester system, but that's the kind of way that you can evaluate something like that.
Got it. So what's that? Can you run a thermal loop down East Center? Is that here? Do they mean here?
Yeah, when you're looking at that residential area east of the Mayo Civic Center, Justin manages some property through First Homes down that way. So I think it's kind of a question to see if he can connect long-term to the system.
He's baiting you.
He
He's
is.
saying, get it down.
I think so.
This is a really good question, the next one, and I can see it, so I'll save Kevin. Can a natural gas pipeline be retrofitted to flow thermal energy? It really depends. I would never count on it, but when you have a good consultancy or an engineering group come into your town, they're going to look at everything. They're going to look at how are the service water lines, the fire mains, can they be used? And, you know, of course, we've got the wastewater lines. So natural gas is something we're very interested in repurposing if it's not an old iron ductile or leaky natural gas system. If there's a good high density polyethylene system, we're going to evaluate it for reuse. Absolutely. But we've never been able to do it yet. It's a great idea, however. We just haven't been able to apply it yet. Uh-oh, Christy, this one's for you. Public health. What does it say?
Suggest creating a presentation for co-op boards in New York City about huge cost savings alignment with local law 97, which eliminates fines. Co-ops are massive in NYC compared to the rest of the state, where different tactics should be employed.
Do you have any comments on that, Christy? Yes.
Yeah, I agree. Unfortunately, the local law 97, the co-ops are going to have to deal with the local law 97 until the either New York City or New York State decides that there's going to be some leeway for them. But you know, I agree. Some of the co-ops are coming up against some really hefty fines, and some of the lower and moderate income residents there are. It seems really extreme, some of the fines, but local law 97 was put into place so that decarbonization and renewable energies have a chance to be put into action. And there's got to be a way they can come to a fair and equitable means. But that's for New York City to really work out. But I do agree with you. There's some stiff fines there that need to be more equitable.
Thank you.
And I think we're approaching the end here. So do DX systems require special approvals and wellhead protection areas? maybe handle these one at a
Yeah.
time.
So when you're talking about DX systems, there's two ways to think about it. But what I think what Sadie is saying here is DX systems, meaning direct expansion with the earth. There are very competent DX systems that are produced. And you can go online and Google direct expansion geothermal systems, and you will see that there are thousands in the ground for more than 40 years, especially in their really hot areas for these. But each local area has their regulations. So special approvals, where we've seen them installed in certain states throughout the country, it's practically no regulation because it's considered extremely safe to do direct expansion. But are there additional considerations that need to be evaluated given the critical nitrate and other emerging pollutants in the area? Once again, that's a regional consideration. We have to go through and meet with the AHJs, look at the local codes, and decide if there is any reason to red flag or move forward with that. So I think we're down to the last one. You want me to read it?
Sure. Go for it.
Does geothermal offer any co-benefits related to stormwater? That is a great question too. Carter, do you have any thoughts on utilizing stormwater, or Greg for utilizing stormwater for thermal exchange?
Yeah, I mean, it's one of the many resources we talked about. One of the things that makes these systems so hard to talk about, at least concretely, is that there are just so many ways to pull in sources and things. But no, that's a totally viable resource that you could plug into your district energy system.
All right, I think we're at the end here. We're 1 minute ahead of the hour, so maybe if we have time for one last final question of our team. All right, hearing none, really thank everyone for attending today. Really thank our EggGeo team. I'm going to make everyone dizzy doing this. Appreciate them being here, providing that great presentation. And we'll see you next month for the next sustainability series. So thanks a lot.